bubbly, 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 burn, burn, burn. It's chemistry! Woohoo! Let's do some chemistry. Yeah! Try to get through it. Got my nice flower hat on for the month of May. Yeah, nice. We'll be working on reactions, kind of how reaction pathways work, kind of looking at how reactions take place. We're going to talk about the collisional theory and the model of collisions for chemical reactions. We're going to look at a little bit of reaction rates this week. We'll progress through chapter 17 fairly slowly, but we should be able to make it through section 17.2 by the end of next Friday. This week we're going to work on 17.1. And so primarily today I'm going to be talking about basically the reaction pathway. I'm going to mention reaction mechanisms. I'm going to look at activated complexes. I'm going to look at activated energy, all kinds of fun stuff like that. And so just kind of bear with me. There will be about 3 questions on Google Classroom. You guys have till Wednesday. On Wednesday, we'll look at more about reaction pathways, and we'll be actually drawing out reaction pathway diagrams, looking at delta E, which is a change in energy from reactants to products, that kind of fun stuff. And so, yay for funds. Chapter 17. All right, well, let's kind of look at this. We're going to be talking about, like I said, the reaction process. So reaction process. We're going to look at something pretty straightforward. Let's look at a basic reaction. We're just going to pretend where we have A, B plus C, D. Maybe those two react together to form A, D plus C, B. That's our overall reaction. And so that's what we see at this large scale as the reaction is completed. But we have to understand is that most reactions aren't single steps. They're composed of multiple smaller steps. I introduced it last chapter when we talked about Hess's law and reaction mechanisms. So we've got to look at a mechanism. A mechanism is a set of smaller reactions. So let's just pretend maybe this is what actually has to happen. Maybe AB decomposes into A plus B. Maybe. And then maybe A plus C, D, maybe those actually run into each other and hit and form AD. And then maybe you have a C floating around that runs into that final B to form CB. Well, if we add everything up on both sides of the equation, what we're going to find out is that A cancels that A, everything cancels out. That B with that B, and then, I've got a C floating around somewhere. Oh yeah, there would have been a plus C here, right, because of that, right? And then we have that. Well, our overall equation is going to be the sum of the individual steps. So that's what we'd call a mechanism. It's valid if everything cancels out and it gives you the same type. So with a reaction mechanism, though, if we just take this example again, I'm going to clear all these drawings. So again, we have AB plus CD reacting to form AD plus CB. That's our overall reaction. Again, our mechanism looks something like this. AB reacts to form A plus B, right? And then we had A running into CB to form AB plus C, and then that C runs into that leftover B to form, what did I do? Oh, D. That's what I did. D. And then that CB runs into each other to form CB. All right, so there's our 3-step mechanism. Again, I made a little mistake there with the B's and D's, but I think we'll be okay with that. There's our little 3-step mechanism. So the rate of the overall reaction is always going to be determined by the slowest step. You're not going to have to identify which step's the slowest. I'll probably be telling you that. But we see some things that don't exist in our overall. We see this and this and this and this. Those don't exist. Those species we don't see up here at all. So we call those intermediate species. Those are species that are going to be transitionary. They're going to exist for a moment in time and then be consumed throughout the rest of the reaction. Like I said, it's an intermediate. They don't exist. We'll talk about them as being activated complexes eventually, but we'll save that for Wednesdays when we actually look at these pathways drawn out with activation energy and whatnot. So that's how a reaction happens. Now, for this stuff to actually occur, if we look at this is breaking apart, so that's okay, but what has to happen to these two? What has to happen to these two right here to form this? Well, they have to run into each other. So for a reaction to occur, That, now what was that? I think it was the A plus the CD. They have to actually run into each other. So here's an A, here's a CD. They have to run into each other, right? And maybe if they run into each other where the A hits the C, nothing happens. So maybe that A has to run into this flipped around, right? So there's two things we really have to take account of. We have to talk about the number of collisions. They have to collide, they have to interact for a reaction to occur, and orientation. So are they hitting in the right orientation for the reaction to occur? These two things are really, really super important because you have the right number of collisions and you have the proper orientations, things are going to actually happen. If we think about enzymes, those little biological catalysts that help reactions happen in the human body, really what they're doing is they're providing optimal orientation of the little bits and pieces that are reacting, which is kind of cool. A lot of times catalysts do that. They provide for proper orientation or sometimes an increased number of collisions. You can utilize catalysts that way as well. And so really, when we start looking at this, reactions are completely based on collisions. Again, those collisions are going to be super, super important. And they have a pathway. There's a reaction mechanism, which is the sum. Now, I'm going to have you identify a reasonable, I'm just going to say, is this a reasonable mechanism for this reaction? And if so, label an intermediate. They're going to be fairly simple questions. Just make sure you understand that vocab from the first half of section 17.1. And we'll look at the second half of 17.1 on Wednesday when we actually start diagramming, where I do something like this and I say, here's our reactants, and they go to products, and we'll talk about this as being activation energy, and we'll talk about this as being delta E, right? We'll do all kinds of fun stuff with an actual reaction pathway. Our activated complex or intermediates are up here, and I'll draw them all goofy-eyed and funny up there for you, okay? Otherwise, hopefully we understand the vocabulary used today and in the chapter. We are just going to keep moving on through. Wish I got to see you all, but for another day. Keep working hard for me, guys. I appreciate you and everything you do. I will have office hours tomorrow if you have any problems with the questions. I probably will not post the questions on Google Classroom until this evening, which is Monday, or tomorrow morning when I'm going through and working on that stuff. Okay? All right, guys. Have a wonderful, awesome 4th of May. May the 4th be with you.